Hello, welcome to our webinar on API design. I am Brian Malloy with Apogee. You can find me on Twitter at Landlessness.
And I'm Marsh Gardner. I'm at Earth to Marsh on Twitter. Today we're going to be talking about API design. The title of the talk is Pragmatic REST. And so we'll be walking through, we'll start off with what is Pragmatic REST, how does that compare to regular REST, how does this affect design. Brian's going to give a bunch of examples about actual APIs out there in the wild and give some patterns that you can follow. And then at the end we'll wrap up with some questions.
Great, so let's get started. The hashtag for this webinar is API design. If you've got questions, you can either do it through the webinar interface there, or you can go ahead and do it on Twitter, and we'll be paying attention to that stuff. We have these awesome free stickers that say I love APIs. If you're interested in snagging one of those, send a tweet to Apogee, or go ahead and send us an email at info@apogee.com. All right, Marsh, kick us off, babe.
So Pragmatic REST. So this isn't REST, strict REST in the way that Fielding defines it, and so in some ways you could say this isn't REST at all. But there are lots of great things that make REST beautiful and wonderful, and the Pragmatic REST, the way we think about it, is that the key is that it's the design of your API should be centered around adoption. And so everything you do, you need to think about how that design affects the adoption of your API. Because you don't make an API for nobody to use it, and that obviously everything you do that facilitates its adoption makes it take off faster.
That's right. So this might be wrong in terms of pure REST, but if loving you is wrong, then I don't want to be right.
So, Fielding, REST comes from Fielding's dissertation. It's interesting, and it's definitely worth reading through the things he's written about it. And then there's a great chart that Brian, if you look at his tweet stream from yesterday, you'll see he pushed this out. That it's an excellent, really helpful classification of HTTP-based APIs. This came from a discussion where we discovered this through discussion on LinkedIn. There's a group called REST Architects. Lots of good conversation that happens there. And this is one example of the kinds of things that people share. It's helpful, and it takes you through the various classifications for how you can think about how RESTful an API is or isn't. But ultimately, we probably fall in the tier with the two green boxes. That doesn't mean that one is right or one is wrong. Just depends on your perspective and where you want to start.
That table was helpful, but it's pretty dense, didn't you think? I mean,
it's dense. It's dense.
It's a lot to grok.
Oh yeah. And actually, I think we should definitely do a blog post about how to reduce that down into something that's
something a little simpler.
Yeah, a 5-minute version.
Right, but we can rest at night because now we have a couple cells on a table that we know we occupy.
Exactly.
Right?
Exactly. So REST is certainly ascendant. Everybody talks about their APIs being RESTful these days, and why it's winning is in some ways summed up by this here. If I want to make a request to the Twitter public timeline, it's something I can do in my web browser. Whereas before, the popular APIs that came before were, for instance, SOAP APIs, where you've got to build a whole package and put it all together, and it's an XML and just not fun. So you think about the differences between what's involved with packaging up in the mail, a package which may have a manifest and a bunch of contents in it with an address and all sorts of postage you've got to calculate, compared to what it's like to create a postcard. Obviously, there's a whole lot less friction in making API requests when you're thinking in the postcard level than when you're dealing with packages. So it's also, if you then look at even just the trend in REST APIs moving towards JSON, compared to having to deal with XML, which is heavy and verbose and needs to be parsed, you can see that pattern again. It's the patterns that thrive are the ones that are easy.
Right on. And that would be a really, really powerful analogy, like if it were 1957 and people actually still sent postcards to one another.
Fair, that's fair. So I think that if you want to take what Pragmatic REST is really at its core, it's two things. One, the URL is the least common denominator. My mother, sorry mom, but my mother understands what a URL is and how to enter that into an address bar. It doesn't get any simpler than that. How do you get simpler than that? You have any ideas? Because that's the next kind of APIs.
After the postcard, man, I have nothing. I don't know how you can keep on that.
And those URLs are all mapped to HTTP verbs, that represent CRUD, the create, replace, update, delete. So you've got get, put, post, and delete. It's pretty elegant. It's built in as part of HTTP, and it's those two things keep it really simple. And so everything, for me at least, derives from here.
All right, so we're going to dive into a little more detail around how to create a RESTful API, and I'm just going to be going through stream of consciousness here, and Marsha's going to interject, and if any questions come in that we can pick up, we'll gladly address those as we go. One of the things that we think is really important when it comes to doing an API and making it useful is this notion of affordance. It's a pretty well-known design principle, and this picture sort of illustrates that best. These handles, when you see them on the door, by the physical design themselves, they're inviting you to pull on those handles. That's what the design invites you to do. But for whatever reason, the door isn't designed to work that way, and they try to make up for it by putting this push label on top of it, which is really trying to put lipstick on a pig, right? You can just imagine people coming up to this, trying to pull on the door, yanking their arm socket out, and only to realize that it's supposed to be a push affordance. So a lot of what we do in this design session is to talk about how the URLs in an API should really teach the developer something about how the API works as you go along. And there's sort of a corollary to this, and we kind of have this pretty strong opinion about how pure REST can get a little over academic and not very pragmatic. And a lot of the people we talk to that are sort of the most passionate about being really pure about REST are actually architects. And architects provide a lot of value. They can focus on how to make a system really scalable, how to focus on edge cases so that and there's nothing that the API can't accomplish. But we like to make sure that folks understand that a good architecture does not imply you have good design. They're actually two different problems, and oftentimes when you're most successful, they're actually accomplished by two different types of people. Architects are really good at thinking in the abstract, whereas designers are really good at thinking in the concrete. Another way I like to say this is, on the one hand, there's two kinds of science, right? Like Newton's second law, force equals mass times acceleration. It's a really powerful abstraction of some important physical phenomenon, and from it you can derive all kinds of great stuff. That's one kind of science. On the other hand, you've got folks who study butterflies and do these really rich taxonomies of every single variation of butterflies. API design is much more like the latter case. It's much more about detail, not about the abstract. It's about making something feel very obvious when the developer approaches it. So, getting a couple design principles. Do you want to say something?
Before we move on, I was just going to say that for me, architecture for me is what it affects how the back-end system's put together, whereas design affects how people use it. And so, obviously both are important, but right now we care, and our point with Pragmatic REST isn't about the back-end system as much as it is optimizing so that it gets adopted.
That's a really good point. And it's don't fire your architect, or if your architect, don't stop thinking about APIs. You need both. You need the good back-end architecture, but that's not enough, right? You need somebody who's really thinking about, okay, how does the developer approach this? Great point, Marsh. So a couple of design principles we want to touch on. This is sort of, I think, one of the most important ones, because engineers and architects often make this mistake. It's the design principle called the flexibility-usability trade-off. The idea here is really simple. As the flexibility of a system increases, its usability decreases. And oftentimes, as engineers, I know in my past developing code, it's easy to keep striving for ultimate flexibility to make a system really powerful without being aware that that's not an unending virtue, right? Flexibility is great, but it is going to come at the cost of usability. So you'll see we'll justify a few of our decisions as we go based on that principle. The second thing is really around empathy. If you need to empathize, if you're creating an API and you're thinking about the design, you have to empathize with the developer. The developer is going to be going through like 4 distinct phases around that design, and you should be aware of how your design will be viewed as the developer is in each of those stages. All right, so let's get started with the good stuff. So, in our opinion, if you're on your way to having a good API, you will only have 2 URLs. And what we mean by that is 2 base URLs per resource. And they'll look like this. So the first one is for a collection. So we're going to say that we're modeling dogs, for example. And this is what our first URL looks like. /dogs. It should be obvious if I do a get on this, I will get a listing of all the dogs. Our second URL is for a specific element from a collection. So in this case, I would say /dogs/1234, where 1234 is in place of an identifier. If you have a design that has more base URLs than this, you're probably doing it wrong. Where we get all this power is, as Marsh mentioned at the beginning, is we have these really interesting verbs that are the HTTP actions that we can apply against those two base URLs, post, get, put, delete. A lot of folks memorize these. I actually am older school. I memorize create, read, update, delete, and then I map those back into the HTTP verbs. So for me, I end up with a table that looks something like this. There's a great article on Wikipedia. If you do a Google search for REST, you'll see this a table similar to this. I've tweaked it a little bit just because I think it's important to make to have only one way to do things and to error fast if things don't make sense. But essentially, this is where all the power comes from. If I want to create a new dog, I do a post to dogs. What that is saying is give me a new dog element inside the dogs collection. If I want to get a list of all the dogs, I do a get on dogs. If I want to update some attributes about dogs, then I do a put. And if I want to delete all the dogs, then I do a delete on the entire collection. And then we apply those same things again, but to a specific element. It really doesn't make sense to do a create on an existing element. So we suggest you error out there. If I want to get a specific element, like a dog named Bo, I'm going to do dog/Bo. If I do a put to a specific element, it'll update it. And if it doesn't exist, it should error out. Some folks will say that if it doesn't exist, you should create it, but I think that gets confusing, so I like it to just be simple and deterministic. And then finally, you do a delete, and you delete Bo. So check out that Wikipedia article, and you come back and check out these slides. We'll have them up on SlideShare shortly. But that's the overall idea, and for me, this matrix represents all the power in a REST API, because with just those two URLs, a developer can start to learn a lot about how the system works, and then as you start to look at other resources, that self-similarity will pay off. So what does that all mean? Putting verbs in your base URL is a bad idea. Nouns are good, and plurals are better. This is an important point. We talk to a lot of people who design their API, and they're really careful about a lot of details, but then if you look at the actual resources and how they're identified, some are singular, some are plural, and that just means every time you change it, the developer is going to have to look it up every time he goes to use it, because there's no consistency in the way that works.
And it makes me think of when tagging first became popular, and the question was, should you tag in the individual way or you should tag in the plural way? It's the same kind of thing. It's the way you think about how that organization, that data is structured.
Yep, right on. And the reason we pick plurals over singulars is it just reads a lot better. If you say get dogs, you're getting a list of all the dogs. Where if you say get dogs /1, 2, 3, 4, it's kind of obvious you're talking about a specific element in that resource. All right, what about associations? Here's how associations work. So let's say we have a specific owner who has a bunch of dogs. We would do it in the following way. We essentially just chain the resources together. So in this case, I'm going to do a get on owners /9876, where that's the identifier of the owner, /dogs. This will give me a list of all the dogs owned by that person. And then secondly, there's the next idea is if we wanted to create a new dog for the owner. In this case, you do post on owners /9876/dog. So this would give us a new dog for that specific owner. I think there's some feedback that I'm talking too slow, so I'm going to go ahead and try to talk a little bit faster. Is that what you're trying to say when you wrote slow in capital letters? That I was going too slow? All right. What about complex variations?
If you had an API, I would have definitely updated it.
Yeah, you've done a put on velocity. All right. So what about complex variations? This is oftentimes people try to overload variations. Everybody's like, hey, my API is too complex. I can't make it like a simple REST API. And there are cases where that'll be true, where you can't narrow it down and pin it in a corner so it feels like a REST API. But those are very rare, and we'll talk about those in a minute. For many cases, though, it's best to put all the complexity out of the base URL and kind of sweep it behind the curtain, so to speak. And how we do that in an API is to put it behind the question mark. So here's some examples. If we wanted to get, say, for example, all the dogs all the red dogs running in the park, you could do something like this, where you would actually put those attributes behind the question mark in the parameters. Another really common scenario, everybody's gonna have to think about this at some point, is how do you handle pagination? You don't want developers making an API request and you send back 400 terabytes of data from the database. You want to make sure that you are intelligent how you do pagination. So what we're going to do now is take a look at how some of the big dogs do it, the biggest guys in APIs, and we'll give you our biased opinions about everything that they're doing wrong or right, stuff that we agree with. So here are three: Facebook, Twitter, and LinkedIn. Facebook does this notion of offset and limit. LinkedIn does start and count. And then Twitter does this thing where they have page and RPP. Marsh, you're kind of the Twitter guy. Do you know what RPP stands for?
Request per page.
Now, did you know that inherently? Was that built into your?
I don't think I would have known that.
You had to look that one up.
Spent a lot of time with their API.
Right on. So the problem with RPP is first of all you would have to look to know what that means, which is going to slow someone down right at the onset. And then, more interestingly, the Facebook and LinkedIn examples, they use different language, but it actually has the same meaning, right? This is the same approach that you do with a database, where you do an offset and then you limit. Twitter, on the other hand, it actually has a different meaning. Like you could swap the numbers from Facebook and LinkedIn with no problem; they're both going to work. But when you try to do it to Twitter, you're going to get funky results. So they're very different. Our suggestion with pagination is to do it the way that Facebook does, and the main reason for this is for developers. This is a really common scenario that you do with a database query. You do a limit and offset. And the two biggest databases, both Postgres and MySQL, the open source ones, they do this. So it's a known set of semantics, so we suggest if you're doing pagination, use limit and offset and stop thinking about it. Just move on to the next problem that you have to solve.
But it's also, though, important that the API will never, ever get used if you don't get it out there, right? Mm-hmm. So while there's certainly these principles, and they're important, and you need to consider them, and everything you do up front is great, perfect is the enemy of done. If you don't get it out there, no one will use it. But other than that, I think one of the key pieces, and you want to make sure that it gets called out in what you were saying, is that things should be obvious, right? So the RPP isn't obvious, and therefore it's not great. So
we're striving for great pragmatic REST. Think
about websites that we've all seen them, the ones that have URLs that are incredibly impenetrable, right? It's a post ID or something like that, or every page has a different unique ID. That's pretty terrible.
Yeah,
it's terrible for SEO, but it's also terrible for the hackability of those URLs. And it's the ones where you can clearly see what's happening in the address. I mean, it's a resource locator, right? So if you can see what's happening and understand it just by looking at it, then you're winning. That's great.
Right on. Great point. And speaking of getting it out there early, we want to move on to versioning. So this is kind of this is a warning area. We know that there are many things in the approach that we're about to suggest for versioning. There are many use cases that cannot be accomplished. So we know that when we talk to REST purists, this is where we take the biggest amount of grief, and people treat us like a voodoo doll and beat us all up.
Sure.
And you took this wonderful picture of these two road signs you're on a trip somewhere.
Yeah, that's in New Zealand. It's at the Fox Glacier, and it's unfortunate you can't quite see it. But the guy who's fallen into the water, I assume he's been hit on the head by the rocks and has fallen into the water. He's actually got googly eyes. Somebody's come by and modified this. Very nice.
When I first saw it, I actually thought it was it meant like party up ahead, that they were guys in the water. Nice. Hooting and hollering and having a good time.
Yeah. Well, okay. And of course, and then best of all is that so you have signs because they're iconic and you should be able to understand them without any language. But I think here is a situation where the signs just start explaining themselves particularly well, because at the very bottom they have to tell you exactly what what it is you have to do to avoid this scenario.
Right.
So I think in terms of great design, this would not be a fabulous answer.
Right. And I would argue that if a developer stopped there, it's because he thought that was a double negative. It's like bang no stopping. So it's no stopping. So feel free to stop whenever you're tired.
Right on.
All right, so let's get into the versioning stuff. So here's how a few of the big dogs handle versioning. Twilio, which is a fantastic telephony-oriented API. Their business is just APIs. Salesforce.com and Facebook. So Twilio has this really interesting and powerful approach to doing versioning, where you actually put the timestamp of when your code was written in the URL, and then they'll figure out which version of the API you were actually trying to request. It's really powerful. Unfortunately, when you look at this URL, it's not abundantly obvious what that first string is. In fact, when I first looked at it, I thought they just reversed the order, and that might actually be like the account number or something like that.
Funny.
Yeah, so I had a hard time parsing what that one was. Salesforce.com has this thing where they say version 20.0, like 3 spaces over on the URL, and then Facebook makes it an optional param. If you go if you do a Google search on Facebook API version, all the top hits are about errors, about broken applications, because people didn't realize that the API would be versions, so their apps didn't include the version number, and then Facebook changed the default version to something new, and their apps broke. So the Facebook approach is essentially the worst possible solution that you could take. So what do we think is the best way? There's a couple simple rules. One, we do believe that the version should be in the URL. There's a bunch of really interesting use cases that you won't be able to handle with this around nested APIs where the results link you to other API calls and so on, where you would want to put the version in the header. We feel that those are outliers and they shouldn't be the thing that dictates your first level design that the developers have to encounter. So instead our rules are put the version in the URL, number one. Put it as far to the left as humanly possible. That's rule number 2. Rule number 3 is put the character V in it. We know what that means. We know if we say V1, V2, it means version. As developers, we know that stuff. And then rule number 4 is don't use a decimal point. It's going to help keep you honest. An interface should be an incredibly slowly changing thing. You don't want to have version 20.0.3 because it's going to imply all the wrong lessons both for your developers internally and for the folks who are consuming it.
So I think we could probably spend an entire talk just on versioning.
Absolutely,
right?
we could.
And so really though, what you need to think about is that you never ever want to change your API unless you have to, because you don't want to break things that people are depending on, right? Mm-hmm. And so your API. This is why having the dot makes really no sense. While you may have internal builds and they may be important to you in terms of diagnosing what's happening on your API, that kind of information should be sent back in the header. So really, when we're talking about versioning, we're talking about two things: the version of the API, which is a contract with your developers that you're not going to break things, and then the build number that is going to come back in the header that can help you diagnose issues later, that represents your own internal code base. Both are pretty important.
Right. We just checked the Twitter stream. Just because you don't disagree, that doesn't mean. Just because you don't agree with us, that doesn't mean you're a REST purist, which isn't a bad thing either. You can definitely be a REST purist.
Absolutely.
Yeah. So we'd love to hear it. If you got things that you think are wacky or not, as pure as they could be, we'd love to hear about it.
And so, I tend to think about the versions of your API in terms of like epochs, right? So it's it's like
I like that word.
Well, there's the Iron Age and the Bronze Age, or those were ages, I guess. Maybe they should
Eras.
be ages.
Right. The epoch represents the beginning of the era.
Yeah, okay.
So I think maybe you're using that word right.
Yeah, correct me.
Right.
But they should be big changes that happen infrequently, right?
Yep.
So it's important.
It's almost
a big
like
deal.
punctuated equilibrium.
That's Sam's
That's
star.
a different talk. Okay. Let's do our next topic. So here's the idea of please give me exactly what I need. Mark, you talk about a lot about the Twitter API, how you really get too much stuff back.
Well, Twitter doesn't presume that I'm going to need certain pieces of what comes back. So a great example is when I query a timeline, I get back an entire element just about the user and all kinds of information that probably aren't necessary to the exact use case that I have for whatever I'm querying that API for, right? And that's a lot of data, and I don't need it all. So Twitter actually has a way in which to trim the user out of that, and that's really helpful. But then there are other patterns that are more flexible and let you determine opt in and out of the fields that you need back.
Cool. Let's take a look at some of those. So here are 3: LinkedIn, Facebook, and Google. They all have different approaches to how a developer would get just the parts of an API response that they want. It looks like this. LinkedIn has this interesting syntax. I think internally they even call it the emoticon, where it kind of looks like a sad face, and then they group the attributes inside. Facebook has a really simple parameter called fields, and then you just specify the fields that you want. And Google, who we're pretty sure pioneered this approach, they also use fields, and you have the really interesting ability to actually nest the selections that you want. So if one of the response elements is actually an object itself, you can further define which elements you get back from that. Our suggestion here is to make it as simple as possible, and we sort of like the Google approach that Facebook uses as well. Specify the fields, make it as simple as possible so that it's human parsable, so the developer can figure out what's going on, and make it at least simple on the first pass. If you want, you can further give them the ability to filter out the nested stuff, but at least make the first level stuff as simple as possible. All right, let's go on to the next bit here. So what about formats? This is another area where we start to definitely go out of bounds with the design of real pure REST and how it's supposed to work. So let's take a look at that stuff. Here's how 3 folks do it: Google Data, Foursquare, and Dig. Google Data, you specify a param called alt, and you drop in there what kind of format you want. Foursquare does .json right in the URL, and then Dig gives you 2 options. You can either use an accept header, or you can use a type attribute or a type param in the URL. Now notice that they have a little qualifier that if you specify both of these and they're different, say you put XML in the accept header and JSON in the type header, you have to figure out how to resolve that. So their approach is to say if the type argument is present, it overrides the accept header. So the biggest thing that's wrong with the dig approach, and I'm going to use this as sort of an example that we see a lot of people make in terms of serious design flaws, is as soon as you give a developer more than one way to do something, you're going to be naturally increasing the amount of time it takes for them to make a decision. And they're probably going to have to look things up and then think about how they resolve ambiguity. And this is a principle from the Universal Principles of Design called Hick's Law. The time it takes to make a decision increases as the number of alternatives increases. So there's really no added value in having those two ways to approach the format, but it really does slow down the development of for the developer. So here's our suggestion. Use .json in the URL. You'll see we have a general tendency to say put things in the URL as opposed to the header, because if they're in the header, they're invisible. Whereas if they're in the URL, you can't ignore those. We already know how to deal with file extensions. We've had the file extension metaphor in our operating systems for a very long time. Mm-hmm. So anybody looking at this, it should be pretty obvious that what you're going to get back is a .json, a data with .json in it.
Yeah, I mean, it also plays to our whole point about what pragmatic REST is, that it's the API, the URL is the least common denominator, right? The same thing here. When you think in terms of file formats, we already have a commonly understood metaphor for how that works, and why not use it?
That's right. And it happens to only take one extra character beyond what is needed to specify, right? It's just that little dot at the end. So we like that it's got the brevity characteristic. That's good too. All right, next thing we're going to tackle is searching. So we're going to use searching as an example, but this is really a type of URL pattern that we see. So imagine that you had a service that would calculate how much tax needed to be applied against a sales transaction. That's not necessarily a URL lookup that's hitting a database on the back end, so it doesn't really make any sense to model it as a RESTful URL. And it's the same thing with search. You're really performing more like an algorithmic type thing where you're doing something that doesn't necessarily feel like it hits a database. So we suggest being really clear about this and do it the way that Google does. So for example, if you wanted to do search, we want be sure that it feels like a noun. Be sure it feels like a verb instead of a noun, and then just drop parameters in behind the question mark. So if you want to do a global search, you would have /search question mark and then whatever your full text query is. Likewise, if you were doing some kind of tax calculation, this would be /calculate and then your query params after that. So everything should be a noun in a REST API, but if it's not, make sure it's a verb and avoid ambiguity around the types of API calls that you have. Okay, what about errors? Errors are really, really important when it comes to an API for a really simple reason that might not be intuitively obvious to most folks, and it's the following. Developers learn through errors. If you're writing code, you're not reading the manual, you're just going to start banging out your application, and you're going to learn what you're doing wrong and how to do things right by the errors you get back from the system. It's of paramount importance to think about your error strategy for your API. It's how you're going to help educate developers about how things are supposed to work and how you want them to use it. So here are a couple simple rules that'll help you make the decisions about how you do your errors. So here's another brilliant picture from some of Marsh's explorations around our planet. Where was this taken, Marsh?
I think this is also New Zealand. I think New Zealand's got a real talent in funny signs.
They got the best funny signs, huh?
They may.
Very cool. Okay, so let's take a look at how 3 of the big API providers do errors. Facebook, Twilio, and SimpleGeo. Facebook, no matter what you send in to the Facebook API, the HTTP status code coming back is going to be 200. So no matter what you do, the word from Facebook is, it's all right. Everything is good. And instead, they actually put the error message inside the response. Twilio, they do a great job, one of the best jobs overall, and you'll see on the next slide how we talk about that. They provide an error code that closely matches to what the actual issue was, and they do something really brilliant, which I think everybody should follow. They give you the error code, which usually I hate if there's nothing else to complement. They tell you what that error code is about, but they do this great job of giving you a link back to the Twilio website, to their documentation where the URL actually includes the error code in it. And you have to think about something really powerful that can happen here. As soon as you have that link, it has an identifiable URL. Once you've got that, you can put commentary and discussion right on top of that error page, and you could power it with Discus or anybody else like that pretty quickly. And now developers can start teaching one another what the error is, what's causing that error. They can talk about how to resolve it. So before you even need to get in there in the mix, there's already going to be the community built up around that error code. Simple Geo, they do the status code and they include a message in the body, but there's no new value added. So here's the simple rules to keep in mind when you're doing an error for API for developers. 2 rules. The HTTP status code is for the program. The code is for the code. That is the thing that the logic in the program will parse and react to in order to work on the programmatic flow. The message is for human beings. Oftentimes, by just kind of reverse engineering the error message you see back, the developers who built it must be thinking that they're trying to conserve bandwidth. Don't conserve bandwidth on errors. Be as verbose as possible. Send everything you can across, including follow Twilio's example and have a link back to your error page. But be verbose. Even if you're not sure what might be causing this, give hints, because remember, this is the darkest hour, the darkest minutes for a developer when he's got an error and he can't figure it out. So tell him everything you've got, and by versioning it on the website, you can actually you don't have to do a code release every time you want to update what the errors are.
Did you register teachdogrest.com?
I don't remember if we did that or not.
You better jump on that.
Yeah, I had to pay for somebody thousands for it later, I'm sure.
So there's new stuff obviously popping up all the time. Google for JSON. I think this is an interesting wrinkle. I think I found out about this from Jonathan Berry from Magento. It talks a little bit about, and I think it's something that's worth more discussion at another time, but how much of the metadata about the response to an API request should be in the actual response itself. It's an interesting question, and I think JSON is looking to address that to some degree and to come up with some kind of standard. Will it be that? I don't know, but it's worth discussion.
Good points. Check that out. Google it. Talk to us about it.
JSON.
Bingo. Whoop. All right, next topic. What about the rest of the URL? So we spent a bunch of time talking about just assuming that the sort of top-level domain was taken care of, but we want to dig into that for a second because we think some of this stuff actually matters to developers in terms of how easy it is to find your API. So let's look at Facebook, Foursquare, and Twitter. Here are all of the sort of the URLs that map eventually into their API. Facebook has 2 API URLs, graph.facebook.com and api.facebook.com, and then they have developers.facebook.com, which is essentially their developer portal where folks go to learn about the API. Foursquare does api.foursquare.com, and then they also have developers.foursquare.com. Twitter has not 1 but 3 different API URLs, api.twitter.com, search.twitter.com, and stream.twitter.com, and then the developer portal is at dev.twitter.com. I know why teams have these multiple URLs floating around for their APIs, because you can do a lot of interesting routing at the DNS level by picking up a new subdomain and sending it to a different set of servers. But this is really bad news for your developer. It separates the resources from one another in probably a way that just doesn't really add any value. It doesn't teach the developer anything about your API or how to use it, and it just becomes cumbersome. They probably have to write 2 different libraries with 2 different URLs in it. We think it's kind of disrespectful to do this to your developer. Even find another way to get those gains that you're trying to get, or do the migration that you're trying to get instead of using the subdomain. We really suggest keeping that as one URL. Do you agree with that, Marsh?
Well, yeah, no, I'm fine. I was actually just going to point out in seeing this slide here that it's kind of interesting when you go to these different endpoints in a browser. So if you go to graph.facebook.com in your browser, it actually directs you to the developer portal. I think that's a really nice touch.
That is brilliant.
Isn't that clever? Now, if you do that with the Twitter API, if you go to api.twitter.com in your browser, you're actually going to get the Twitter website. So that can be confusing.
That's
right?
not very thoughtful.
Imagine if you get that back,
right? Because
you somehow screwed up the request you're making. That doesn't help you understand what you're doing wrong.
You got it.
It's not good.
That's a great point. So to that point, here are the things that we recommend. Well, I changed this on you, Marsh. I wonder if you're going to agree with this.
That's a go. Let's see.
Yeah. So we think
I'll tell you.
All right. The API URL. We think it should be API dot whatever your top level domain is. Your developer portal where you're going to connect with your developers.
Did you make it plural? Is that what you did?
Marsh and I used to agree that this should be dev. We thought that 3-letter thing was good. Yeah. But I've gotten beat up on this so much when I'm talking to people out in the real world that I changed it to developers.
Yeah. Okay.
Yeah.
Actually, I think it's really interesting. GitHub just released their beta version of their V3 API.
Yeah.
The version 3 of their API, and it used to be on develop.github.com, and you can still find the documentation for V2 there.
Okay.
But now their V3 documentation is on developer.github.com.
Okay, singular.
Singular.
Yeah.
Anyway,
Okay.
I was confused by it. There wasn't an easy way to move between the two.
Yeah.
And
GitHub that never does anything wrong either, so we probably can figure out what they do almost everything exactly right.
But they're human.
Yeah. Sometimes they wipe the database on you, but other than that,
Yeah,
they're a strong company. And then this is the point that Marshall was making on the previous slide about web redirects, right? If you're visiting something if somebody comes to your API URL in the browser, go ahead and redirect them to your developer portal. Assuming that you can parse. They're not actually trying to make an API call. It's a friendly thing to do.
It would be bad. I think it's really helpful sometimes when you can make a request in your browser and get your response and see it.
Well, that's absolutely true. But if you're going to the base URL, then if there is no response behind that, you might want to redirect them. Because they're not asking for .json or anything like that. Just take them to the.
We can fight about this.
We can fight about it later. Okay. All right. On to the next.
Hockey season.
We're dropping the gloves here.
Jersey pull all the way.
All right. What about the defaults? So I think we agree on this. That the default format for APIs nowadays should be JSON. It's terse. It's what the cool kids are using.
In fact, some APIs are even dropping support for XML, right? So
I hadn't heard that.
This Twitter streaming API doesn't return anything but JSON right now. I think the Foursquare V2 of their API, I think they may have dropped XML.
Wow, that is very interesting.
Yeah, it's definitely happening. And why is it happening?
Why is it happening?
Why is it happening? Oh, it's happening. I mean, I think the biggest reason it's happening is because you get a native object back. You don't have to parse it in JavaScript. I think that's a big deal. Really helpful.
That speaks to the ascendancy of JavaScript as the.
I mean, I still like XML. I think it's easier to if I have to write something that's going to be be machine readable, then I find XML is a little bit easier for me to write personally.
Okay.
But it's not about me. Most data is coming from machine to machine, and it works better when it's JSON.
Gotcha. Great. Good point. And then pagination. Pick a reasonable limit on. If someone doesn't specify the pagination parameters, you click, again, you don't want to bring back the whole database to them. So go ahead and make some smart decisions. We say if you've got kind of small size data, make the limit around 10. Sometimes you have really tiny data or really big data, and then you want to adjust that accordingly. But just pick a smart limit based on what your data is all about.
There's a great tweet that I love here from that I first saw from Will Norris who gave his opinion on XML versus JSON for APIs. He boils it down to the fact that JSON makes it much easier to accidentally do the right thing. And I think that's a great way of thinking about it.
I like that. Yeah, that's an overall design philosophy too. By having things visible in the URL, you get some of that same benefit. You can accidentally figure it out and accidentally get things right instead of dealing with how do I put this stuff in the HTTP header and construct all that.
Help people fail in a good way.
There's a whole nother. There's a book there.
There may be.
There's a book deal in there somewhere with a nice 50K advance for you.
Do you know Tim O'Reilly?
Yeah, we'll get to him.
Oh, good.
All right, now there's some interesting. What we just covered is kind of like the sweet spot of doing an API design. Now we're going to get into some of the exceptional stuff.
And we got to make sure to save room for questions at the end too.
Yes, we got to zip through this pretty fast. This sign is actually from Sam Ramsey and I discovered this sign together while we went mountain biking in South San Jose.
Nice.
Somebody scratched out the S and the D in control your speed.
Excellent.
You noticed that?
I particularly like the way that the sign itself is also leaning, suggesting that this is important.
Well, I actually kicked that sign over to take the photo. It was a perfectly upright vertical sign before I got there.
Dude, leave no footprints.
Yeah, right.
Come on.
Yes. Take only memories, leave only footprints.
All right.
And kick a sign over every now and then. Okay, back to the. So sometimes there are clients. I think some versions of Flash do this. Probably, I think some mobile clients do this, where no matter what HTTP error you give back, if it's not a 200 error, the underlying infrastructure is going to intercept that call. So your developer is helpless. He can't actually intercept what might be some kind of interesting, informative error message. It's just not even going to get to him. It's just going to present itself right to the user. Right, that's what you would call really bad user experience.
Terrible.
So
I mean, that's when I want to have one of those NFL umpire flags. Throw
the yellow flag.
I'm throwing the yellow flag, or maybe it's a red card. Anyway, either
it's a red card. You want to do something referee-like.
The other football.
Right.
Yeah.
You want a zebra suit.
Yeah, I do actually.
When you see that, I can understand. Okay, here's how a few folks handle this. Actually, Twitter is the only example I'm going to give, and they do a brilliant job with this. They have an optional parameter called suppress response codes. And if you set it to true, no matter what response no matter what the actual error code is, you're going to get back a 200 saying that everything is okay. And instead, they put the actual error message down into the response. This is a brilliant way to handle this. And if you are working with a client that has this problem, this is exactly the right thing to do. And you notice that this is a nice long parameter name. I like parameter names like that. This is such a corner case type thing. If instead it said, SRC, you would be like, what is this thing for, right? So I like that this is really verbose. It's really obvious what this is trying to do. So then, in this case, always return OK. So you use that response code, and we change our philosophy here. The HTTP code is no longer for the program, right? Now that this code is for ignoring. It will be completely ignored all the time, and the message is no longer just for the people exclusively. It's for the code too. So you would just push those things down in there, right? But this is the exception, and that's what that's all about. So there are cases also where the client, again in the category of exceptional stuff, sometimes the clients do not support HTTP methods. Maybe a certain type of browser can only do can do a GET.
Yep.
So in order to get at the rest of these, we suggest that you put the method name in the URL like this. So create, read, update, delete. You can do the post, put, and delete.
So this is an additional affordance, so that clients that don't have that support can access this.
That's right.
Yeah, I think it's nice to have that. It's optional, but it widens the circle.
Right.
It makes more. Your API can be consumed in more places because of something like this.
That's right. Now we're violating Hicks' law here, or we're in dangerous territory because you're giving somebody more than one way to do something.
Yeah, and
so
we're violating drive. And don't repeat yourself.
That's right. We're violating that too.
But it's because KISS comes before dry for me. KISS dry.
KISS dry CRUD.
Well, CRUD, yeah. CRUD just because it makes you think about resources and updating, creating, deleting, etc. But
is that that growth around your mouth right now?
No,
It kind of looks like a goatee.
They call that a goatee.
Is that from kissing dry CRUD?
Yeah, thanks. It's more important to keep it simple, stupid, than it is to not repeat yourself.
Fair enough.
Want me to say it again?
Why don't you
It's more important to keep it simple, stupid, than don't repeat yourself. Yeah.
I love it. That was really cool.
We'll be here all day.
Right. Okay. Yeah, we're taking this lounge act to Reno tomorrow. Okay, so yeah, I would say don't start with this. You don't want your developer to choose, hey, do I use post in the HTTP method or do I use post as the method param? Clearly, you want them to use post as the HTTP method. This is only to handle that exceptional case. All right, so really we've got to handle all of this stuff and then iterate the API over time too. This gets to be a lot to think about. So a lot of the folks that we talk about that are getting started with their API program, they're trying to figure out how to set this up and manage it in the most intelligent way over time, or even architect the system. Going to give you a couple analogies here. Oftentimes, in an API world, the core system, whether it's a database or some kind of off-the-shelf package, like an SAP or an Oracle or Rails app, whatever the back-end application is, you want that back-end application to be stable. One of the things that comes along with that wonderful virtue of stability is sometimes things are slowly moving. If you're in a world where the back-end system is slowly moving, but the front-end client needs to move very quickly with quick iterations and changes, you're going to put yourself in this kind of interesting spot where you're going to have essentially a frequency mismatch or like an impedance mismatch. So we recommend people to find analogies like cartilage in a bone structure or the middle gear in a gear chain, where you can start to have ways that make the API backend systems and the API clients work more seamlessly together. And what we're talking about here is something that we call an API virtualization layer. So if you say you have a bunch of APIs, it's really smart to put a virtualization layer on top of that. It's where you can do some of these things that we've been talking about in this presentation. And this goes back to the point about architecture versus design. If you create this virtualization layer, then you're giving yourself space where you can breathe deep, catch your breath. You're not worrying about architecture. You're just thinking about, what do these URLs look like? When the developer comes to my API and approaches it for the first time, what's that experience like? If you have this virtualization layer, you're going to give yourself the freedom to make those changes, design it in the right way, knowing that the back-end actual API design is going to do the right thing in terms of architecture.
It can actually help with the architecture of your organization people-wise too, right? You can have people who focus simply on how those back-end systems get exposed, right? So you can have the back-end folk, and then you can have the people who deal with maintaining and mapping how the APIs that are going to be consumed externally on how those map onto the back-end systems.
That's great.
But I mean, to full disclosure, I mean, we're very biased in this way, right? Our company is basically built around this premise that the API virtualization layer is a really important piece of this of transactions with APIs.
That's right.
It's a big deal. So
yeah. And the bit you were just saying, a lot of folks have invested millions, if not $1 billion or more, into their service-oriented architectures, which were very internally oriented. But the core idea of an API is in there somewhere, right? You've got these web services. So a lot of our biggest customers, they'll take that existing service-oriented architecture infrastructure that they built, put this API virtualization layer on it, and now they can make their existing services look like a really smart, modern REST API, right? And it's sort of like an incremental investment on top of your existing investment to unlock huge amounts of value.
Well, it's also, it's super important. A great case for this is the versioning of APIs, right? You don't want to keep the back-end systems as light and fast as possible.
Yep.
And if you can, in a layer, map that back so that the things that you would break as you made changes to the back-end systems didn't break because you could virtualize them back into the versions that fulfill the contract that you'd set with developers before.
Right.
Then I think that's a great reason to have alone right there is a reason alone enough to have a virtualization layer.
That's right. Okay, so to summarize the stuff that we just walked through, be RESTful.
Be RESTful. Yeah, so be RESTful simply. It goes back to what we were talking about with pragmatic REST. Right? Optimize design for adoption. That's the whole key here. You had a bunch of things. Brian said a bunch of really great things, which only I heard.
We usually save the best insights for the offline part of the
That's great
conversation.
stuff.
Yeah. So I was, we call this pragmatic REST, and a lot of folks will say, hey, REST is REST, and you shouldn't have modifiers on it. And I tend to agree with that. So Marsh and I'm going to coerce Marsh to work with me to maybe find a new label for what we're calling our approach to APIs.
Well,
like this.
we're not the only ones, right? There are many.
You're not
most
the only
APIs.
one.
That's right. It's no singing.
Okay.
We have a rule.
Cool.
Lots of APIs are considered REST APIs, but they're not true REST APIs, right? But the thing they have in common is that they're centered around URLs and they use HTTP verbs. Now,
Yep.
So it's wrong to call them REST. But
That's right, chicken butt.
But
all right, so use only two URLs. Don't mix verbs into those URLs. Just use nouns and use nouns as plurals. In my opinion, just put that decision behind you. We're going to use nouns, and they're all going to be plurals, and we're not going to mix plurals and singulars. Just do it all plurals. Sweep the complexity behind the question mark in the URL params. Borrow examples from leading APIs. Look around, find stuff that you like, find stuff that you don't like, and go with the stuff that's good. If you have to, account for those exceptional clients. And think about adding a virtualization layer, at least conceptually, in the way that you're thinking about the API. That's it for our prepared materials. Thanks so much for attending today's webinar. We've got some other ones lined up in the next, I think, 2 weeks from now. We'll have another webinar around launching an API initiative and getting developer adoption going.
And we'll be taking this webinar and wrapping it up and making a version that you can send to friends if you want. If you've enjoyed this, that'd be great.
Yeah, and we're actually, even though we have radio faces, we got a camera in here.
Oh, we do have a camera.
Capturing our every movement, and you guys will be able to see us online. Right.
Yeah.
Did we do anything obscene, facial gestures?
I think they edited that.
They edited that out. Okay, great. Hey, thanks again, everyone, for attending. Please follow us on Twitter. Marsh's handle is Earth to Marsh, and my handle is Landlessness. We have a real terrestrial theme there in our.
We do, yeah. I hadn't
that's
thought
pretty
that
cool.
before.
Wow.
And and don't code like my brother.
All right, rock on. See you all later. Have a great day. Bye.